Welcome back to the LOOC. In this segment we continue looking at exceptions. Just to recall, exceptions are used by try and catch blocks, and the try block encloses code that might throw exceptions, and some of it may be skipped when an exception occurs. A catch block, on the other hand, serves the purpose of catching exceptions. At least one catch block is required after a try block, and the catch block usually specifies an exception parameter that represents the exception that the catch block can handle. The code in the catch block is the actual exception handler that provides a way to continue with the program when this particular type of exception occurred. Optionally, there could be a catch block without an exception parameter that catches all exceptions. This means that all remaining ones that are not caught by specific catch blocks before. If there's no matching catch block and there is no parameter free catch block, then there's an uncaught or unhandled exception, and a window occurs that shows how to find the call stack of it. Where an exception occurs is the throw point, and that's the first line where the exception got caught in a try block. A catch block can have only one parameter, at most one parameter. It's typically an exception type. The class exception is provided in the .NET framework for exceptions, and specific types of exceptions extend or are derived from this class, and programmers can create their own exception types. So exception is the base class of .NET exception classes, and there are certain frequent examples like an out of range array index case. In an array, index out of range exception is thrown, or when the program tries to use a null reference, in other words, we try to use an object that does not exist, or it's out of scope and the memory associated with it is released, then a null reference exception is thrown. Generally, a catch block has a parameter of a type of an exception which is derived from one base class type hierarchy. When we want to determine what type of exceptions to throw, then generally it depends on the method. So a method or function that can throw an exception has associated types, and the Visual Studio documentation contains the possible exceptions. For example, a convert such as convert toInt 32 is can throw format exceptions and division by zero exceptions. The finally block is primarily used to release resources dynamically, such as open file streams or other streams, as well as memory. So for example, if we open the file, then the file should be closed before the method terminates, otherwise a resource leak occurs. One type is the memory leak, that is for the most part is taken by the common language runtime using a system called garbage collection, but it's not guaranteed that every memory leak will necessarily be caught, and also the timing of it depends on the operating system and the CLR itself. So when there are resources that we definitely want to release, then we often use a finally block, because a finally block executes regardless of whether an exception occurs or not. So if we are using a method that possibly throws an exception, but prior to that point, say open the file, even if we close the file in the method itself, after at the end of the try block, that code may not ever be reached, and if an exception happens in particular, then we never get there, and therefore releasing resources is best done in the finally block, because it is guaranteed to execute in either case, whether an exception happens or not, and we use that type of construct to release memory and file streams and so on. We need to know that local variables of a try block cannot be used in a finally block. So resources should be released as soon as they are no longer needed, so then they are available for reuse. So in the next program, we look at a situation that contains a finally block, and we'll see that it always executed regardless of whether there was an exception or not in the corresponding try block. So here is the program, the way it starts. Class using exceptions with the main method calls a number of methods that are coded later. The first one is does not throw exception. The second one throw exception with a catch. Then the third one is that throws an exception without a catch. In other words, an unhandled exception occur. And in the try block, we call this method, and there's a catch block that it catches any exception. Since this catch is a general catch block that does not have a parameter, this catches any exceptions. The first is that a method throws an exception, catches and rethrows it, in which case we call the method again in a try block. We have a general catch block to catch all exceptions, and follows, and that's the end of the method and the main. So here are the methods. Does not throw exception, it's just an output line, and has a general catch which is never executes because the console write line will never throw an exception, and the finally will be always there at the finally block as evidence that it always executed. But of course its purpose is generally to release resources. Then the throw exception with catch. In this case, in the try block, after the write line we throw a new exception. We call the exception base classes constructor. It's with a single parameter, which is a string, and then we catch it and display it, and then we put in the finally block to show that it executes. Throw exception without catch, we throw a new exception, again The exception base class constructor is called with a single string parameter that will become the message, but no catch, and a finally block with indication that it got executed. Any code after that will be never reached, of course, before, because we threw an exception in the try block already. Throw exception catch and rethrow. In the try block, it throws a new exception with a single string parameter, and it has a exception specific catch block to catch that example, and the throw keyword shows that this method will rethrow the exception, by default the same one that the catch handles. So in this case it's a general exception, but with that particular message that we passed in, so it will rethrow the exception, this catch, and this can happen when the method that called this, in this case it was the main, but in a more complex program there could be a caller method that has an exception handler for a particular type of exception, so we rethrow it, and there is a finally block to show that it executes. It's the end of the code, and the output will look like this. So the first method is called and ended. It does not throw an exception, so there's nothing remarkable there, but the finally block message is there, showing that the finally block got executed regardless of whether there was an exception or not. There's another one which handles an exception with a catch in the next method call, but the finally block is there again, showing that it got executed, and the end of message is there too. Throw exception without catch, again it throws an exception, doesn't handle it. As a result, we never reach the end of the try block and never got beyond it. However, so there's no end method. However, the finally block is still executed, and the exception rethrowing method again rethrows the exception, but the finally block still executes. So if we throw a new exception in the finally block though, then the original exception is lost, so we create a new exception in this case. If there is code to throw an exception in the finally block, then this typically is included in the try block, so that there are no unquote rethrown exceptions. And generally, try block shouldn't surround all code, because then code would become very difficult to develop and maintain. It generally should surround blocks of code, so larger code segments that can throw exceptions. So let's look at the previous program. So here is the using exceptions class and the main method. So within the main method there are the cases. The first case, no exceptions occur in called method, so we indicate which method we are going to call, and we call it, does not throw exception. The second one that throws an exception and handles it with a catch statement. The third one is the method that does not handle the the exceptions, so we throw it without, we call that method that throws an exception without a catch block. And the fourth one is the method that does a rethrow. And here are here is the code for the individual methods: that does not throw exception, a try block, a catch, which will never actually catch anything, so it will never run, and the finally block that is on the other hand always executed. The second method is the one that throws an exception and handles it itself as a catch block and has a finally block as well. The next one is similar, throws a new exception but doesn't have an event handler, so it won't be code, but there is a finally method. Note, however, that when we call this method, it was placed within a try and catch pair of blocks, so that the exception eventually gets called, but not within the method itself. The same is true for the next one, that rethrows the exception, so the calling of it is within a try and catch block to make sure that the exception gets caught. So here is the method that follows, which throws an exception and rethrows it, catches it but rethrows it, throws exception, catch, rethrow. So in the try block it throws a new exception, it catches it and then rethrows it, and the calling main method try block and the following catch block will catch this exception, but there is the finally block here too. So that's the program, and if we build it and run it, then we can see it work as expected. In other words, we catch all exceptions and handle them, some of them within the method that is locally, some of them in the calling method, and got some warnings, but should work fine. So here is the output until it becomes complete. So the four methods, and the important thing to realize that some of them have unreachable codes, so the third one doesn't have an end of message, and but all four of them have a finally block, and the finally block is always executed, and that's why it's the place to put resource releasing code, because it's guaranteed to execute regardless whether an exception was thrown or not. There is a using statement in C# with the syntax shown. So we basically call the constructor of the object in the as a parameter of the using statement, and in the body of the using statement we call a method. If any exception can be called, then this structure will catch it, because it's the equivalent of this longer code when we call the constructor of an object, and it basically the equivalent of calling the method and placing a finally block in which, if the object actually exists and is not released from memory, then it will be released. The memory release happens with the dispose method, and in order to be able to call the dispose method, we have to cast the object into the iDisposable interface type, and the dispose method can be closed, invoked, that will release the memory associated with this object. During debugging, the exceptions provide a message string that indicates what kind of exception it was, and the stack trace that calls the method call stack, in other words, which method called the next method called the next method, and so on. As methods are nested into each other, it shows the entire calling trace, starting from the throw point and going all the way up to eventually the main method. Sometimes programmers need to create a new type of exception, and for example, in an accounting problem, in a program, an account amount error exception can be written, but all these have an original exception object that is now the inner exception of this newly created exception type. And there are other properties such as help link, source, target sites. So in the next program we are going to see a number of methods calling each other. So within the main function there is a method one call followed by a catch that catches basically all exception types, and we display the exception parameters, and itself, the object itself, converted to toString, converted to a string, and because console write line implicitly calls toString automatically, then we display the message component of the method, the stack trace of it, and the inner exception object. Then we go on to method creation. So method 1 will create will call a method 2, and method 2 will call a method 3, just to show the method calling stack unbinding, and eventually method 3 has some meaningful code, a try block in which we try to convert a string that is not an integer into an integer, of course thereby causing a format exception. We catch it and we rethrow it here so that the caller methods will have a chance to receive it, and then we get a stack unbinding tree. So it will look like this. So the first line, exception parameter toString, indicates where the exception happened, and it's method 3, the innermost, the last called method. And the message is that the input string is not in the correct format, so it's a format exception. And then it shows the line numbers and the stack unbinding. So within method 3 it was line 49 that the exception happened, that where the toString line was, and line 54 was where method 3 was called by method 2, then line 40 is where method 2 was called by method 1, and line 34 is where method 1 called method 2, and finally in line 45 14, we call in the main method we called method 1. So here is the stack trace, repeating the basically the same thing, and the inner exception, which again shows the inner exception object, and it shows that the original exception was a system dot format exception with the message, and then the location where the exception happened. So if we look at this program, then we have in class properties the main method. So on line 14 we are calling method 1, so that line will appear in the stack unwinding in the stack in the method called stack, and then in the catch block we display the exception converted to string, its message and its stack trace and its inner exception object. Then we build the sequence of caller methods. So method 1 calls method 2, method 2 calls method 3, and finally in method 3 we on line 49 we actually throw the original exception, which is a format exception, and catch it, and instead of that we create a new exception and we throw that, which means that at this point the original format exception became the inner exception object of this newly created method that we display in the original catch block in as the last output. So the inner exception will be displayed that, which is not the inner exception object of this new exception that we created in method 3. So we can compile and run this program. And we are going to get some call stacks displaying. So here they are. The output starting up, so again pretty long. High. So the first one is, cannot really make it any wider. So the first one is the exception is handled in the main method, displaying the object itself, displaying its message and displaying its inner exception, and its message and its stack trace, and we are going to see the stack unwinding. So line 49, so basically going back line 14, going back to 34, 40, 57 are the lines where we called methods that cause the stack unwinding. So that's those are properties of parameters. And to recap, the main method is the bottom, so they are as typical of stacks listed in reverse order in the stack trace, and the throw point is at the top, and the inner exception is included in the inter-exception stack trace. In the next segment we look at user-defined exception classes.